In our previous video, we discussed a few ways our sun could get destroyed, or at least get unstable. Technically, there were 3 different ways, but there is another. If you already read the title of this video, you know where I'm getting at. Instead of hoping for a supernova to hit our sun or waiting possibly millenniums to develop an antimatter gun, what we need to make our sun and the rest of the solar system go numb is simply a black hole. I admit, there are very few things that are simple when it comes to the idea of the black holes. In this video, we're going to discuss how black holes are created, what they are exactly and what keeps them alive, and why do they die. Oh, and after that, we can go for the fun part and weaponize it and throw it at the sun, just to see what happens. It's going to be a wild ride, so relax, get comfortable, and enjoy the video. You probably already seen this picture. It was kind of a meme back in 2019. This is the first ever picture depicting a black hole. Remember, we theorized and proved that black holes exist at least 100 years ago. The first theory of an object with a mass so great to pull everything in it came back in 1784. Then, this guy Einstein did some formulas. Then many other scientists did their thing. And at some point, it became probable that an object as crazy as black hole could exist. But it wasn't until 2015 when we first detected the gravitational field that belonged to one of these black holes. And it took a few more years before we got a glimpse of it. So, what is black hole, you ask? As you will hear in this video a lot, that's a bit hard to answer. Very simply, a black hole is a region of the space-time that has a very strong sense of gravity. Yes, black holes are so strong they suck in even something as strong as light. Imagine a sphere that is very dense and sucks in everything it gets near to. That's a pretty good explanation, I think. Once I understood this while doing a research, the next question in my mind was, how the hell are these black holes created? So, let's answer that now. We know that a gravity is the result of an object having mass. The more mass an object has, the bigger its gravitational pull is. A black hole can be created if a star with the diameter of the Sun is multiplied by a factor of 500. That's our Sun's diameter, multiplied by our Sun's diameter, multiplied by our Sun's diameter, rinse and repeat that for another 500 times. When an object, in our case this star, is that big, it also has a high mass. It's funny, we can't imagine something as massive as a star that's 500 times bigger than our Sun. But hey, we can at least try. So, if this massive star becomes massive enough, it can crumble itself. Imagine a house crumbling on itself because it can't support the mass above it, while a normal house would just release that energy and be done with it. The star crumbling on itself creates what we call a black hole. Imagine how big that star was when I described it earlier. And now, imagine all of that mass contained in a sphere and that sphere in the size of a point, like a dot on a paper. That's called a singularity. A dot with a mass of a giant star. The singularity has an event horizon, basically a big sphere around it, and when a piece of matter crosses that event horizon, it is officially sucked into a black hole. A singularity with an event horizon is how you describe a black hole, just like you would describe a ball with a core and a surface. As the legendary Obi-Wan Kenobi once said, this is where the fun begins, and you'll understand why in just a second. If we go with the most accepted theory, after a dense star becomes a black hole and reaches some form of stability, it only has 3 independent physical properties. Those are mass, so theoretically you can weight it. It has an electric charge, which is pretty self-explanatory, and it has angular momentum, meaning it has a direction in which it continues to go during its lifetime. A black hole doesn't have any other features. So, Technically speaking, if two black holes had the same mass and angular momentum, we wouldn't be able to tell the difference, except for the fact that they would be in different points in space. The funny thing about this is a simple fact that it's a theory, so it can be completely false. And on top of that, using modern physics, we can't explain how black holes last for longer than a second. The next question I got was, where does all of the mass suck into the black hole goes? Imagine you have a cup and you start pouring water in it. At some point, the cup will become full, after which you can't physically pour any water into the cup. You can pour something denser in it, like oil for example, and a cup of oil would have a bit more mass than a cup of water. But at some point, you reach a point where both cups become full. So, then the question comes, how can a black hole suck in so much matter without getting filled up? Here comes another fun thing. Technically speaking, a black hole is a massive star that crumbles under its own weight. Normally, a star is born when the atoms of light elements are squeezed under enough pressure for their nuclei to undergo fusion. So basically, light particles that are in high pressure. Now you can think of something. Anything that can suck vast amounts of light and also has a very high mass, hence creating a perfect opportunity for the star to be born. Yes, theoretically speaking, given enough luck, a star can be born inside of a black hole. That's how some black holes can end their lives of destruction. What's so funny about that, you can ask? Well, the funny thing is that I just made the last part up, and if I didn't point it out, most of you wouldn't doubt what I said. That's how much we know about black holes. Even the things that we know are just theories supported by facts, but theoretically, all of that might be false. And that's what's so funny to me. The sheer amount of straight-up lies I could write about black holes, and most of us wouldn't be able to tell the difference. Anyway, enough of that self-doubting critique. Let's now get to the even more fun part of this video. So, we generally know how a black hole is created. You take a lot of matter, you condense it by a factor of 1,000,000 or 2, and there you go. And I'm pretty sure you know where I'm going with this. What if we could make some sort of machine that can make matter crumble on itself? If we take something as massive as a skyscraper and condense it into the level of a hydrogen atom, we could get a thing called a simple black hole. Those have a mass, so they can suck things in. But they neither have an electric charge nor angular momentum. So, they won't electrocute you, and it stays stationary. What are the black holes? Since the skyscraper is a bit less massive than our planet, the simple black hole we just created won't be able to destroy our planet. However, it can destroy a lot of things. And by destroy, I mean to take anything that has less mass than it and break it into the simplest of particles. That means that if you were to get sucked into that simple black hole, you would be divided into hydrogen and carbon atoms, which, if I'm honest, would probably suck. That brings us to the earlier question. What happens to matter that gets sucked into a normal black hole? And the answer is the same thing that I just described. Then the next question that I got was, how does a black hole cease to exist? So, imagine a car engine. If the car is turned on, it starts to use the fuel to power its actions. When you run out of fuel, it just stops. That's close to what scientists theorize could be the end of black holes. Simply getting to a point in space where there isn't enough matter to keep the black hole party going. It can slowly start to lose its mass. Where does that mass go? We don't know. Could you find the traces of that black hole? We don't know. Could a black hole exist forever, given enough matter in its path? Yes, there is a theory of primordial black holes, which states that a black hole created shortly after the Big Bang could still exist. and we wouldn't know it because we can't carbon date a black hole. Well, just like the intrigued person that I generally am, the next question I got was, what could be on the other side of the black hole? Or rather, where could it lead us? Well, you do remember that we could not explain why a black hole does what it does using traditional physics. Well, the thing is, we also have this thing called quantum physics, which is a beast in and of its own. And in the future, we will surely talk about this. But using quantum physics, it is conceivable to theorize that. Wait a minute, we didn't do the fun part of the video yet. What if we took a black hole and threw it at the sun? That's a cool question, right? Just like I said earlier, with the man-made simple black hole, it depends on how big of an object we will condense into the smallest atom to create the black hole. For example, if we take that skyscraper black hole and throw it at the sun, most likely it won't have that much of an impact. However, if we decided to take our moon and condense it to the size of an atom, then it still won't be massive enough to suck in the whole sun, but it certainly has the potential to disrupt its stability. And if you watched our last video, you know that if the sun becomes unstable enough, it will start dying earlier than it normally should. And if that happens, we would die because of it. But to give you some peace of mind, most likely we won't be able to make the sun unstable using a black hole. Not because the laws of physics don't allow us to do that, but because we would already be dead by trying to create a black hole instead. Now, going back to the early question, what could be waiting for us on the other side of the black hole? As I was saying, using what we know about quantum physics, it can be conceivable that if we manage to get into singularity without dying, we could reach the… And that's it for this video. Join us next time to find out what could possibly be waiting for us on the other side of the black hole. Will we ever make that video? Maybe. But that's surely a great cliffhanger, isn't it? Consider subscribing and slapping that like button if you like this video and want us to make answer to that last question eventually. Thank you for watching, and we will meet in the next video. Until then, have a peaceful day.